Thank you, Saraswati. You can hear me? Yep. Okay, as you can see, the title of this talk. Okay. All right. Yeah. As you can see, the title of this talk is Building Energy Efficiency in the Global and Indian Context. And this is the stuff that you're going to see on the screen has been prepared largely by Mr. Samir Mettal, and I'm going to say what he wanted to say, but I'll say it on his behalf, and then some stuff that I've added on along the side of it. But you know what the purpose of this whole thing is to recognize the importance of what we'll be doing this week and what we hope to launch ourselves into in the coming future. Just to recognize that importance. That's very important for us. The second thing is to say, in this big picture of this very complicated world and climate change and whatnot, there's such a big picture there. Where is our activity located? Where is it located? And if we recognize where that activity is located, then we know what its impact can be, how it becomes useful. So it's really about the big picture. I'm sure you know, all of you know everything that is going to be said here. Everything. It's just that I'm trying to tell a story that puts it all together to answer or to underline those 2 points that I mentioned just now. Should I just do it like this? Yeah, that works. Right. Anyone here who doesn't know what global warming is? We all know what global warming is. And so it's clear enough that it is happening and it's been proven. Okay? Anyone here who doesn't know what it is being caused by? We all know, right? And it has to do with the concentration of carbon dioxide in the atmosphere. And much of that concentration is being caused by carbon-based energy production. So coal, petroleum, gas, carbon-based energy production is releasing carbon dioxide, apart from the fact that there's deforestation, that is another cause of carbon dioxide emissions. But this is a major thing that is happening. It's because we, in our modern day, have become dependent on this damn thing, on carbon-based energy production. And we have to now somehow see how we can withdraw from it if we are going to do anything about climate change. That's the big picture. And there's some history to all of this. And what the scientists have been telling us is that this concentration of carbon dioxide in the atmosphere has been gradually increasing. And so this is just a graph to say that it has now crossed 400 parts per million. And they also say that if that concentration remains high and it gets higher and higher, the globe will get warmer and warmer. And that is happening. What we also know is that as a consequence of this concentration, the temperatures of the globe are rising. Sea temperatures and air temperatures are rising. And if you look at this is how it goes? Yeah. This thing here, all right, this thing here is called a hockey stick curve, right? It says that this is going to go more and more vertical. That's the tendency that we've been seeing. And this hockey stick curve is paralleled by a certain type of modern building activity, which is also a hockey stick curve, right? That we think that we are doing great things as we grow taller and taller. We think we are doing great things as we defy the climate outside and get the ideal conditions inside our spaces, no matter what, by pumping in lots and lots of energy. not only in keeping the places cool or comfortable or warm or comfortable inside the buildings, but also in defying wind and gravity, going taller and taller. We think we are doing great things, right? But there is a direct parallel between this hockey curve and this hockey curve. Just recognize that. And so it's about a change that we need to project, that we need to engineer, that we need to make happen in the culture of buildings. That's what we need to do. And then we also find, this is also scientifically established, that buildings, and I'm not talking about cities at the moment, just buildings, right? If you take cities and buildings as a complete system, that's an even worse picture. But just look at buildings. Buildings consume a lot of energy. And there are two kinds of energy consumption in buildings, all right? It is, the energy is consumed in the making of buildings, right? And energy is consumed in the operation of buildings. So the energy consumed in the making of buildings, we call it what? Embodied energy. We all know what embodied energy is. No further clarification required. And there is an energy in the operation of buildings, right? So keeping the lights going, the ceiling fans, air conditioning, ventilation, blah, 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 pumping water, and so on and so forth. All of that is the operation of buildings. And now we know clearly that globally, building operations and production of building materials contribute, what's 28 plus 11, what's the 39, is it? So say 40% of carbon dioxide emissions and the responsibility of climate change is directly attributable to buildings. And that's why it's so important. Yeah? And you can see if you add transportation along with cities, etc. So built environment actually is a more complex picture. And so the way we make cities and the way we live in cities, the buildings and the city systems going up and down and managing the city space, distributing all the services, etc., is going to be responsible for good 40 to 45% of what's happening. And this, I think, is probably the most crucial picture, that till now, we've been able to blame Mr. Trump for everything, right? The Americans are the big culprits in climate change, and followed by the Australians, and then followed by the North Americans, and followed by the Europeans. They are the guys who have consumed so much energy and material, and they are responsible. We are the poor folk, we hardly consume anything. But you know, the picture is changing. You go to China, India, Mexico, Nigeria, Brazil, the picture is changing. Societies are developing, populations are growing, and very soon we are going to be the bigger contributors. And that's what we have to watch out for. And not only that, what's happening is that as we become a little better off, we need more built space per person. As we become better off, I need a restaurant, I need a cinema, I need a college, I need a school, I need this and I need that. So the per capita construction activity also increases. And so there's a big increase. It's not proportionate to population increase. Population increase multiplied by wealth, leading to much greater proportion of building demand, and that in itself has both an impact on operational energy as well as embodied energy. Yeah? So, well, this you can see that the increase in built-up area that is being projected is not proportionate to increase in population. It's a function of the multiplication of population and wealth, all right? And also the fact that you're going to be building more and more in the cities. Now just imagine that you have another 50% addition of built space in 1 decade, and that the embodied energy, the type of building that we now start building, multi-story, reinforced concrete, steel, glass, plastics, aluminum, blah, 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 that intensity of embodied energy is also increasing per square meter of built space. And that is going to be done across the country, 63 cities of large populations, growing all in 1 decade. You know what this is? This is a bomb. It's a bomb that's exploding simply on account of increased building activity of a certain kind. Okay? That's the story of embodied energy. And Samir says that he's going to pick this subject up briefly, although that's not the core of what we're going to do here, but he's going to pick that subject up. And here's another piece of information, very important. When you talk of operational energy, you know, there was a time when we thought that, you know, it's commercial buildings, ECBC. We all know what's ECBC? Energy Conservation Building Code. What is it meant for? For which type of building? Commercial buildings. Why? They consume a lot of energy. Yeah? But actually, if you look at the global perspective, it's the residential sector that's consuming more energy. And that it is consuming more and more energy. So consumption of energy in the operation of residential buildings is again not growing only in proportion to population, it is also growing as a result of improved incomes. Yeah? And so that's a big thing that's just coming to us, and it's this story of thermal comfort. I designed buildings for people who have just come back from California. They came back from California, and they're working in an IT office. And then I said, you know, we are designing for 25, 26 degrees centigrade, and you can open the windows when you feel like it. The guy says, he turns around and says, hey, what are you talking about? I can't work if I'm not comfortable. Those guys will refuse to work in this hall. They'll say, I can't concentrate. I'm too uncomfortable. Give me 21, 22 degrees centigrade. All right, that's what they're asking for. So this kind of demand for what we call air-conditioned comfort is just, I don't know, it's growing without control. And nobody is questioning it, let me tell you. Nobody. And the air conditioning industry, they're very happy with it all. Yeah, they're very happy with it all. And some of us are involved in the air conditioning industry, right? So just watch out. Now, this is important. As we look for air-conditioned comfort, even in our homes, and we've seen this around where we stay, everybody is sticking this indoor unit, this kind of stuff, and there's an outdoor unit just outside, right? And the moment you feel uncomfortable, you press the button, boom, and it starts consuming electricity. What happens to that electricity? It turns into heat outside. You pump the heat from the inside to the outside, and you add the heat that you consumed as electricity to the outside. And what have you done? You have now created a hotter outside of the building. When you created a hotter outside the building, what do you need to do? You need to do more air conditioning. And therefore, a vicious cycle is set up. And what does it lead to? Quite apart from the changing of surfaces in building mass that produces the urban heat island effect, anthropogenic heat produced by mechanical and electrical devices that are meant to operate the buildings, to make them more comfortable, add to the urban heat island effect. All right? So you see now, this thermal comfort business is a crucial business. It's a crucial business. You really got to control it. You really got to bring it under control. And that's what we are going to be focusing on. What happened? Yeah, this is just to show you what people are doing. Right in our neighborhood. Walk out, go 10 kilometers, 5 kilometers this way, outside this city, in this city. This is what people are doing. Bade style mein, shisha, you know, view, baapre, kya baat hai. But what do the residents have to do on the right-hand side? What do they have to do? They say, oh, it's too hot. Oh, parda lagao, ye lagao, wo lagao outside. So, and who's driving this? Now, I was talking about the engineers and the air conditioning industry. Who's driving this trend? The rest of us, the architects. We are driving this trend, the architects. Okay? We are. So, each side is 50% of the culprits. That's the tendency. Well, you know, we need to, as Saraswati said, buildings are complicated things, and there are many things that go into the building. There are many stakeholders that have to come and work together. So this is just a picture that shows, yes, there's a planning and arrangement of buildings, and there are many components of the buildings, the inside, the outside, the external skin, the shading systems. All of that has to come together now to deal with this question of thermal comfort. Very, very, very important. And housing, even low-cost housing designed for thermal comfort is going to be very crucial. Because even if I have a teeny-weeny house, 30 square meters, 40 square meters, today to live in, when I am a little better off, I will ask for better comfort. And if my house is not carefully designed, my air conditioner, which I'm going to install, is going to be consuming much more electricity. It'll run for much longer, and it'll run at higher capacities, and so on and so forth. So people say, you know, this energy efficiency is about those commercial buildings, those high-tech buildings, those complicated buildings. No, no, no. It's about this one as much as anything else. Simple homes also have to do something with it. So operational energy, thermal comfort. That's the core of what we're going to do here in this workshop. Operation in this camp. These two numbers, or these two things that we just mentioned. And this is claimed by our friends at Green Tech. They say, you know, if you get it right, you can potentially drive down the carbon dioxide emissions by 40%. 40%, all right? In other words, if globally buildings are responsible for 40% of carbon dioxide emissions, it can definitely be brought down substantially. And certainly, it can be kept down as we grow as an economy, as we grow as a population. It can be kept down. So that is what we are trying to learn, how to do that. And this has been done for many institutional, commercial, and now even residential buildings, as Saraswati just showed, a comparison of her house to the one that's built in Rajkot. And, well, just to repeat what Saraswati said, because it bears repetition, this, I think, is extremely important. Climate comfort, buildings and climate. That's kind of a theoretical framework. What is climate and comfort? Comfort for whom? For the polar bear? For the ant? For the old person? For the young person? For the lady or for the man? For people dressed like this or dressed in another way? Comfort for whom? And in relation to climate. And how do buildings interact with climate? What is the impact? You know, when you do something like this between the outside and the inside, what happens? What are the principles that determine that? That's something we need to understand more precisely, more precisely. Then you begin to say, okay, you know, this thing that we do around us as building has to do with our comfort. And if that is not sufficient, we'll have to add some devices to make it more comfortable, which we call HVAC, or artificial lighting. And then, even that mechanical and electrical means that we deploy, we must understand their engineering really well so that even that can be made very efficient. So that's the sort of sequence of things that we are looking at. And finally, I just want to say this, that what we hope to do in this design workshop is to synthesize the creative capabilities of those who configure and assemble buildings for various purposes. Who are these people? What do they call? What we call them? They are architects. These people who do this kind of work, we call them architects. Those who analyze the environmental behavior of buildings, what do we call them? Sorry? Thermal modelers, yes, but fundamentally they are building scientists, right? They are building scientists. Then those who calculate and integrate structural and environmental systems into buildings, we call them engineers, all right? So architects, building scientists, engineers, they have their different scope of work or different kinds of skills, and we are thinking of how to integrate them as we think of buildings, as we design buildings. This is what we can do before the building is done or designed, and then after that, those who build buildings and install services systems in them, we call them contractors, and those who maintain and operate them are operation and maintenance engineers, okay? And so we are really going to be looking at the first three the set of first three, as if they are totally merged, as if they are totally merged. That's our task. And you know, once we learn to do that, once we learn to work together as a team, feeding on each other's knowledge and capabilities, and informing each other about our field of experience or knowledge, I think we have a much more powerful way of addressing climate change in building energy efficiency. Thank you.